Right, hello again everyone. I'm going to do speed and velocity. This is 10.3 in the textbook, page 282. Now this is a quick one. It only goes for a page, well 2 pages. It's fairly familiar to you from last year, so let's just work through this. Speed is a scalar and this is a vector quantity, okay, meaning it has direction as well. Now the first thing I want to look at is average speed. So average speed is just distance over time. Now often we use the word time elapsed or time taken, so I might say elapsed. Now it mightn't seem very important to you, but you don't want to get confused with time of day. So I'd hate you to say the average speed was, say, 100 metres divided by 12 o'clock. It's not. It's the time elapsed, so the duration of the time. I mean, that's pretty obvious to you. So we use the symbol V for speed as well. And I think you would have done that in grade 10. And we just write a little average here. Okay? And that's just D over T. So there's your first formula. Look, you won't use that very much, but it's there. It needs to be, you sort of need to understand it. So look, I'll do an example in a minute, but let's have a look at the average velocity. This is the more important one. Now this is displacement over time taken or time elapsed. Whoops. Okay, so this is going to be V average equals S over T. Okay, now you could use a delta T to show that it's the change in time, but we generally don't, we just say T. Now these are vectors, and like I was saying before, if you were really keen and you wanted to make sure people understood, they're both vectors. So you can see it written like that as well. Okay, so that's just the displacement divided by the time. Now the other thing is, you'll also meet a thing called instantaneous velocity. Now this is the average. So if you're going for a trip, say you walk to the shops, and it's 500 metres and it took so many seconds. Now you might go fast in one part, you might run past a house with a dog, and so your speed will change all the way through, but you'll still have an average speed or an average displacement, but it mightn't have been an even speed. Okay, your instantaneous speed is just the speed at a moment in time. So for instance, the reading on your car's speedo is the instantaneous speed. So if you're travelling at 60 kilometres an hour, that doesn't necessarily mean in an hour you're going to cover 60 kilometres. It means if you continued on at that speed or that velocity for an hour, you would. But at that one moment in time, that's what the car is doing the equivalent of. Okay, so that's instantaneous speed. It's in the textbook, and it's down the side column. It's in the margin. It's just a little heading that says what it means. But we'll move on. Now look, I'm going to just use a simple example. The one we did before, where I started there and I walked 2 metres and then I came back to there. Okay, now I covered 1, 2, 3 metres, so my distance was 3 metres, my displacement was 1 metre. Now let's say I did that, let's say I took, I don't know, let's say I took 3 seconds to do it, just to make it easy. This was 3 metres in 3 seconds, so this is my time, and I did that in 3 seconds as well. Okay, my V average is D on T, which is 3 on 3 equals 1 metre per second. So that's my average speed. So this is speed, or average speed. So now that's a scalar quantity, so I don't need any little arrows above it, and it's D on T. So my average speed is 1 metre per second. The question is, what's my average velocity? So this is for average velocity. You know V average velocity equals displacement on time equals displacement is 1, time is 3, and so that's okay, 0.33 meters per second. So my average velocity is different to my average speed because of that. Now of course you need to indicate the direction, and like I said before, you're starting here, you go there, this is the displacement. Start at the tail of the first arrow and you finish up at the head of the next arrow. So this is in my plus direction. Okay, look, I'll just finish off with one last example. Now that's a similar one to that's in the textbook, but look, one of the pracs you're going to do probably maybe next week, that'll be week 6, is when you're going to roll an object down an incline. So let's imagine it's a 30-degree incline. Let's say it's, look, I'll make it 90 centimetres. They're about 1 metre long. They're those aluminium ones. I don't know if you use them in grade 10. I bought a lot of aluminium ramps in grade. One of the parents actually gave them to us. It was hundreds and hundreds of dollars worth of aluminium. He gave them to us. You're going to use those, or you might use the thinner ones, but it's about 90 centimetres, and when you let them, you start a ball here and it's going to roll to the bottom. Now you're going to measure the average velocity, not distance, so V average is going to be, S on T. Now S is going to be 90 centimetres. Now you can do that in metres if you like, 0.9 metres. Now let's say it takes T equals 6 seconds. Okay, so it's just over 6. That's, what's that, 0.15 metres per second. Is that right? Yeah, 0.15 metres per second. And that's, if you're saying the downward direction is positive, you'd say something like that. Okay, now that's what you're going to get. But in the prac you're going to measure the average velocity for that distance. Then you're going to do it at smaller and smaller distances and so on. Now the only time this ball would actually be travelling at that speed would be halfway down. Because it's an average, it starts with 0 meters per second and finishes off at 0.15. The average is 0.15. So this V average is 0.15, is when it's halfway down. So what do you think it'd be? Look, I'll get rid of this, a bit confusing there. What do you think it'd be when it gets to the bottom? Well, if it's an average of 0.15, starts at 0, the V final must be 0.3. Okay, meters per second. So that's what you're going to do in the pracs. Any of these things that undergo acceleration, now it's accelerating, it's getting faster and faster. It starts at 0, ends up at a fairly high speed. Anything that accelerates, to get the final speed, you just double the average speed. So it's pretty straightforward. Now that's all I want to do in that section. There's the CYL questions you could have a look at as well. So I'm going to leave that there. There's nothing more to it. Thank you.